We can start whenever you're ready.
Okay, everyone can hear me? I'm ready. And okay, can you see my slides? I guess hopefully.
Yeah.
All right, perfect. Appreciate the thumbs up. If anybody has any more beer jokes, feel free to get those out of the way in chat. Always appreciate them. This is my pandemic project. So my name's Olaf Alders. Today I want to talk about a little project called Perl imports that helps you find out where symbols come from. Before I start that, I just want to thank the organizers for allowing me to speak today and for all the efforts they put into a conference like this. I know there's a lot of work, and I do really appreciate that. Now I know a lot of people here are very familiar with the concepts I'm going to talk about, but I didn't really want to assume too much prior knowledge, so I'm going to start by breaking things down in a really basic way. Okay, let's see. Okay, did my screen? Did we toggle to the next slide there?
Yes.
Okay, great. Okay, so everything's working. Okay, so the initial problem is basically we got the small snippet of code, and there's a three character word in there, get, and the question is, where does that come from? If you're familiar with HTTP request common, then you probably already know the answers to this. If you're not, then it's a bit more difficult. You see that there's this get in the code. You grep for it to see where it's defined. You won't be able to find it. You might ask yourself, is this some kind of a Perl built-in? Did it appear by magic? And in a way, it kind of did appear by magic. And the magic is the exporter module. And the exporter module, when you use a module without any arguments, exporter looks for an array called export. It imports everything that's listed into that array into the calling package. And now you can use all the functions without having to use a fully qualified name like HTTP request common get. Those are just available to you. That's very convenient, but from an outsider's perspective, it can be very confusing. And keep in mind, an outsider doesn't have to be someone who's new to Perl. They might just be someone who's actually not familiar with this module. So the question is, can we make this a little bit clearer? And we can. Exporter has another array called export OK. And in that, you can also define other symbol names that you want to be exportable on demand. So when you pass arguments to a module that's using exporter, it will check to see, does this thing that you're asking for, does it exist in export, at export, does it exist in at export OK? And if it matches one of those symbols, then it provides it to you. There's something else called import tags, and we'll get to that a little bit later, but this is essentially sort of the gist of it. And the idea is that in these cases here, so in the first case, now we've just explicitly asked for something called get, and we are receiving it. And in the second instance, we're asking for something called delete, and we're receiving that as well. So now when we try to grep the code base, these things are discoverable. So they start to make a little bit more sense. The other good thing about it is we didn't import all these other things that we didn't ask for. So we now have sort of like less code to worry about. Now, what's an exportable symbol as far as exporter is concerned? It's quite flexible. So it could be a function. It could be a function that we're actually prefixing explicitly with an ampersand. It could be a scalar. It could be an array. It could be a hash. It could even be a type glob. So it really allows you to share a lot of things. And so some of the more egregious examples would be if you're going to use POSIX. Not a lot of people don't realize this, but just this sort of use POSIX in the statement there, that will import 582 symbols into your package. If you use socket, you get 170. So there's really a lot of stuff that's going on there, and you might occasionally come across some legacy code that just says use POSIX and see you've got like a 5,000 line file, and then you're asking yourself, which of the 582 things are we actually using in this file, or can I even get rid of it? And those questions become a little bit harder to answer. And that brings us to Chekhov's gun. So Chekhov was a Russian playwright, and this quote attributed to him says, remove everything that has no relevance to the story. If you say in the first chapter that there's a rifle hanging on the wall, in the second or third chapter, it absolutely must go off. If it's not going to be fired, it shouldn't be hanging there. And so the idea is when we're writing code, red herrings are not helpful. If you're going to put something in your code, you should use it. And so this principle of Chekhov's gun is really helpful to keep in mind when you're writing code. Now, Chekhov's gun brings us to the next principle, which is Chesterton's fence. And this was inspired by a 1929 book called The Thing. And in it, essentially what Chesterton is saying is, do not remove a fence until you know why it was put up in the first place. And sort of to expand on this quote I've grabbed from this blog here, they say, fences don't grow out of the ground, nor do people build them in their sleep or during a fit of madness. Fences are built by people who carefully planned them out and had some reason for thinking that the fence would be a good thing for everybody or for somebody. So until we establish that reason, we have no business taking an axe to it. The reason might not be a good one or a relevant one. We just need to be aware of what the reason is. Otherwise, we may end up with unintended consequences, second and third order effects we don't want, spreading like ripples on a pond and causing damage for years. So this reads like a principle created explicitly for software design. In production systems, it's a good idea not to remove anything until you know exactly why it was there in the first place. You don't want to set some kind of chain of events into motion that you hadn't intended. And module imports and other code are a little bit like this. Before we change them or before we remove them, we need to understand why they were there in the first place. And this becomes much easier if we know that previously we've been adhering to Chekhov's gun. So if there's something that's there, it's because we want to use it. And then we can apply Chesterton's fence, which says, let's figure out why we need to use it. And then we can figure out if we can get rid of it. So the question is, could we actually automate something like this? And yes and no. So we can get fairly far just by grepping through the code and digging around for docs. Like we saw in the first example, if you're grepping on get and it's not explicitly being called in the import, you won't get very far. You will have to start digging through module documentation. If that module has 30 other modules that it's included, you may find yourself digging through a fair amount of docs before you get to the answer that you need. And that brings us to Go imports. And I've been writing some Go at work, and through the Vim Go plugin, you automatically have access to Go imports, which is a really nice little utility, which by definition, it just updates your Go import lines, adding missing ones and removing unreferenced ones. So in the imports, there are sort of analogous to Perl because the imports there are external libraries that you're pulling into your code. I would give you a live demo of this, but I realized, this machine, Go imports isn't working for me, but trust me, it's magnificent. And essentially here in this Go code, which doesn't really do that much, we're just pulling in some standard libraries and then using a third-party library just to look up a country code. But right here at the top, you can see these are the libraries that are provided to us by the Go language itself. And Go imports has organized them at the top alphabetically. Then it leaves a blank line, and then it includes third-party libraries. And that's essentially it. So if you remove any of these libraries from the code, like say, this was actually called fumped, I believe is the pronunciation. If I remove those lines, like say this one here and that one, if I then save the file and call Go imports, this line here will magically disappear. If I go and try to reorder these import statements and call Go imports again, it will reorder them to the order that it wanted them to be in. And again, if I no longer use this third-party library, that will just disappear from the imports. So it's kind of a really basic thing, but it's nice because it takes mundane tasks and it means that I don't have to worry about them. So can we write Perl imports? Yes. Will it be as good as Go imports? No, it won't. And there are reasons for that. We'll go into those. So the problem with imports in Perl is there's no one standard for importing symbols. And also it's up to the author to decide what happens in the import method. So if we go right back to when you're first learning about Perl, the first thing probably we tell people say on Stack Overflow is you need to use strict use warnings. And those are imports by themselves. They may not realize it, but they're using module strict.pm and warnings.pm. And we tell them that they need to use these things to enforce best practices. And so again, so the pragma is is a kind of a special thing. By definition, it's a module which influences some aspect of the compile time or runtime behavior of Perl. So it's not just, it's not quite the same as saying, give me the get function from this module. So once, you've learned about use strict and warnings, now you're ready to be a little more dangerous. Now you probably will learn about importing an external module, maybe something from CPAN, maybe something else that's in the core of Perl. And we might say, use mojo util and pass it to the trim argument because that's the function that you want. Or use path_tiny, and path_tiny will export some things that it thinks you want as well, like the path function. And we might even say add a number there, and that will give us a minimum version requirement that we can add in the use statement. So that it's important to know about that version requirement, but as far as what we care to talk about today, that's not really important. So I think it'll come up maybe one other time, but we'll just assume everybody knows we can use these, but we won't clutter the examples with version numbers. So what's actually happening when we say use module? And PerlDoc tells us that use module is equivalent to requiring the module and then calling the import method on the module, passing in a list of arguments. And this is all wrapped inside of a begin block. So what's a begin block? So a begin block is executed as soon as possible. That is the moment it's completely defined, even before the rest of the containing file or string is parsed. And begin blocks run FIF, also first in, first out during compilation. So essentially, as the code's being compiled, as Perl discovers begin blocks, it will execute them as it goes along. And if there's an issue somewhere, then it'll bail out. But that's what's happening with the use statements. So, and again, just to break it down a little further, there is compile time versus runtime with Perl. So begin blocks run during the code's compilation phase. So when you're running a Perl script, you're doing two things. You're compiling the code and then you're actually running it. And if you want to check that the code just compiles without running it, that's what the -c flag is for when you're running a script. Okay, so to recap, when we say use strict, use warnings, and then use carp, it's essential to essentially basically 3 begin blocks. And in each begin block, there's a require, and then there's import being called on the class that we've just required. So that's fairly straightforward. But that sort of begs the question, what actually is require? And so just at a high level, kind of hand wavy overview, required does 3 things. So it tries to find the module that we're looking for. It might check for minimum version, like with the version number that we talked about earlier, and then it'll try to eval the code. If you try to require the same module more than once, and if it's already been successfully required, then the actual sort of eval should be the require itself should be a no-op. But there's nothing really stopping you from requiring something several times if you want to. Let's see, I'm seeing some of these comments here. Maybe I'll have to deal with those afterwards. I can't multitask that much, but okay. So in effect, maybe Marijn can answer some of these questions for there. And as far as import goes, so there's import's kind of interesting. So we're calling import on these classes, or are we? So there's no built-in import function. It's just an ordinary method, like a subroutine, which is defined or inherited by modules that wish to export names to another module. The use function calls the import method for the package used. So this is kind of where it gets interesting, because it can only call import on a class that has an import. So if your class doesn't have an import, this part of the use actually will get skipped. If the class doesn't have an import and you're actually passing import arguments, those will just silently get ignored as well. So that kind of could be misleading if you see something like that in the code. Now, there are 3 kinds of imports that we want to talk about today. The first one's the implicit import, the second is the explicit import, and then the third is the empty import. So as far as the implicit import goes, and this is what we talked about earlier, just use POSIX, no kind of arguments. And that's just equivalent to requiring it and doing the import inside the begin block. That's it. And then it will give us hundreds and hundreds of things because it thinks that's what we want. Then there's the explicit import, and that's when we pass an argument. So this would be a function name that we can pass to the POSIX module's import. And then you can see in the example here, very similar to the one before, but now there is an argument being passed in the call to import. And now we've got the empty import. And this one's interesting, and it's the difference between this one and the others is subtle, because you have a list, but it's an empty list. You just have these empty parens here, and you might assume, well, it's just going to do what it does for the other ones, in the other cases, but it's just not going to pass any arguments. But the difference here is that it's just equivalent to just running the require and not running the import. So when you're doing this, if your module is expecting this import method to be called and it isn't, then you might be in for a surprise. So that's something that's helpful to keep in mind. And you kind of mess around this too if you say whether use strict and use warnings and add the empty parens at the end and see if things still work like you were expecting. Now, what does import actually do? So this is kind of hard to answer. So there's some conventions around what might happen when a module's import gets called. And like we talked about, generally, when we say use carp and then give it the croak argument, that means we now have a croak function available in our package. But there's no binding contract that says that has to be the case. That's just a convention. So import, what does it expect? Well, what can we pass to values as values to import? That's left up to the implementer. So in the first example, DDP, that's an alias for data printer. You might pass it a list of options that it can use to format the code that it's printing for you. In the case of test more, you don't directly pass it the names of the functions you want to import. You pass those as an array ref with a key name of import. If you're using test needs, it's not even asking for functions that you're interested in. It's using the import as a way for you to tell it what you're actually looking for. So in this case, it's saying, oh, just assert that we have this minimum Perl version. If we don't, then we're going to skip this test. And then in the case of HTTP status here, we can see the last thing status message, that's actually a function name, but the previous two arguments are import tags, which are essentially aliases. So when you say constants, it's like, well, give me this list of symbols that are defined as being constants, and they'll be available to me, and I'll just know what they are. And if I don't know, then I can look them up. So since import is just a method on a class, you can call it as many times as you like. So there's nothing to stop you from doing something like this. From a code readability standpoint, it's not great, but again, this probably won't trigger any warnings. So that sort of gives us the background of the problems that we're looking at with Perl imports. And sort of the idea is at work, I've got a code base and it's in the low hundreds of thousands of lines, and there are import statements all over the place. We're trying to reduce our dependencies, but it's hard to know what your dependencies are if you're using modules that you don't actually need. So I wanted to have a way to be able to scan the code base, look for all the modules we're using, remove all the ones that we aren't using, and then we can just get rid of those out of our dark pan. So now that we know how to import modules, the question is, how can we programmatically detect which symbols are importable from a module? So the first thing we're going to look at is exporter. And again, in this case, if you use POSIX, if we disable strict references, then we can access directly the export and the export OK lists that are defined inside of POSIX itself. So the implicit imports, the ones that we're just going to get if we don't call the module with any arguments, that's just going to be an export. That's the first line here. And then the second line here is the explicit ones, which, as we talked about, is a combination of export and export OK. So that would then, in a lot of cases, be a bigger list of things that you can explicitly import. Not in all cases. Some modules, it's basically the same list, and which can be an unfortunate design decision. But again, it's up to you how you want to do these things. There's no contract that you need to abide by, really. Now, another So the thing about exporter is it's very popular. There are lots of modules on CPAN that depend on it. I think probably the next popular one would be sub-exporter. And sub-exporter has been around for a long time. It also gets used by a lot of modules. And as the name implies, it only exports subs. So we don't actually have to worry about variables. That's sort of the good part. The bad part is that it doesn't have any package variables that we can expect. There's no export or export OK that we can look at. It has, interesting enough, it has sort of a flexible API, allows you to do a lot of things. So it's probably non-trivial to look at the arguments that it accepts and then try and figure out what's going to happen. And so we don't really want to re-implement sub-exporter or do something really invasive if we can avoid it. So the question is, what can we do in a programmatic way, just to find out sort of in a black box way what sub-exporter might export for a certain module. And this is where sub-exporters groups come in. And the groups are a little bit like import tags. And when you create, sort of when you export through sub-exporter, there are a couple of groups that get created for you by default. One of the default groups is called default. And that essentially would be empty. And that's what you're going to get if you call your module without any arguments, which is sort of a nice default to have, so that you're just not polluting your namespace with a bunch of things. Sub-exporter also helpfully will assemble a list of everything that it's going to export, and it puts that into a group called all. So you can override both of those groups, but this is what sub-exporter does for you by default. And in a lot of cases, that's sort of good enough for our uses. So that brings us to the symbol table. And what is the symbol table? Well, the symbol table for a package happens to be stored in the hash of that name with 2 colons appended. The main symbol table's name is thus %main : or % : for short, which I haven't really seen too often. I did see it in the test suite for the Dancer 2 database when I was messing around with the Perl import stuff. So there's a shorthand that's there. It's good to be aware of that. And so the symbol table is basically where you would find information about the package itself. So lexical variables, something like a my, whatever, you're not going to find in the symbol table, but the functions that are available and package level variables for a package, you will find those in the symbol table. And we can luckily inspect the symbol table. So we talked about, if you haven't declared a package name, you can find your symbol table in main. But if you're in package my module, you can find your symbol table in %my module : And here's just like a one-liner you could try. See here what's in the symbol table here. Let's try this. See if that works. So you can see that there's a lot of stuff that's in here. I'm not gonna get into the ins and outs of all that, but even this is just a one-liner on a package that's package mains. So we actually haven't really done anything, but there's like a bunch of stuff going on here. So that is that's probably all we need to know. We don't need to go too in depth into all this stuff, but let's accept that there's like a hash-like structure that tracks information about what's in a given package, and we can see what's in there. Now, when a package imports a subroutine or some other kind of symbol, those are going to appear in the package's symbol table, and that's the magic behind imports. So, for example, if we wanted data dumper sub in our script, then let me just see here. There we go. If we wanted data dumper sub in our script, then we would just use this syntax here. So basically, the star means that we're dealing with a type blob, and we're just saying, okay, in our main package, we want to have a function by the name of dumper, and we want that to be an alias to data dumper. And then once we do that, we can call dumper without having to use the fully qualified packaging. And it's just there for us, kind of in the same way if we'd written that function ourselves in the package. So that's very convenient. And that's kind of, yeah, that's just basically how imports work. There are modules that kind of add a more helpful or complicated API around those, but that's kind of the basic idea. And we can use the same trick with variables here. And learning a lot in the chat here. I'll have to go over that. And again, I should actually probably say about this that I'm not an expert on any of this. I've just been messing around. So whatever I say, trust but verify. But I have definitely anything I'm telling you, it's I have implemented it so that I know that okay, I should be mostly correct about the things that I'm telling you here. So again, with the variables, we can create an alias to a variable here. So in this case here, we're just creating an alias to a variable called a scalar called dumper version, and the alias will be a data dumpers version itself. And one thing we need to be careful about here is if we increment the alias, that will actually increment the version in the other package itself. So these are essentially basically the same thing, sort of tightly coupled together there. So now enter import into. Import into is sort of the next level of this, and it allows you to import an entire package into another package. So for meta CPAN, we use import into, and we have a meta CPAN moose, so it's our own flavor of moose. And just with these few lines here, we can say, okay, in the package meta CPAN moose, I want all of moose, I want moose X strict constructor, and I want namespace auto clean. And this is sort of a handy way so that you can create your own moose-like module. You don't need to use all the boilerplate that you're expecting in every other module. Just use your own flavor of moose. And you can do the same thing with your own Perl. It's this sort of follows the same pattern. You can have a look at the source code of the link module here, and basically you can just name this whatever you want, even make it all lowercase so that you kind of have your own pragma. And then when you use your own Perl, you're getting strict warnings, signatures, whatever you decide that you want is now available as your own sort of pragma. And then again, same idea, you avoid all the boilerplate and you can use it across your code base and know that you're using things consistently. Okay, so let's put this all together. So we've seen that we can manipulate the symbol table. We can do everything from aliasing a function to importing an entire package. Luckily, sub exporter only exports subs. So how do we track the subs that have been added to the symbol table? So this is our strategy. We're going to take a module. Let's call it my module. And we're going to create a brand new package, some arbitrary name, a package that we haven't required yet anywhere in our code base. So it's got a fresh symbol table. We're going to use my module inside this package. We're going to eval this package into life. And then we're going to find out what changed in the symbol table. Okay, so essentially it would look something like this. So we'll just create a string with our arbitrary new package name. Again, like I said, it's a package that we haven't evaled yet so that we know we're starting fresh. We're going to use a module called simple get. After that, we're going to insert our own use statement into here. So it might be use this module, with it. For sub exporter, we decided we can use it with :all to get us everything, or we can use it without any arguments to find out what happens when we're not requesting anything specific, so that we get the implicit and the explicit exports. And then all we're going to do is create a package level variable called at underscore exportables, and we will call inside a begin block symbol get names on that. And this happens inside a begin block because if we don't, and the module we're using uses something like namespace auto clean, it helpfully goes around and starts removing things from the symbol table before we know that they're there. So we need to make sure there's kind of a race here that we need to get what we want to find out before namespace auto clean tries to defeat us. And then after that, we just can eval this into life. And then we can just check that package variable that we created and see what's inside there. And so, yeah, so the use statement's either going to be the use module by itself or use module all. That will cover both cases for a sub exporter. Okay, so this actually covers a lot of cases. And using these two techniques, we can find out what a lot of modules on CPAN may or may not be exporting. And if those both come up empty, we can use some other heuristics to see whether we actually maybe have an object-oriented module on our hands. And if that comes up empty, then we can actually just throw our hands up and say, we don't know about this. We tried our best. Okay, so if we want to see what Perl imports thinks is in a module, there's a little utility called dump Perl exports. So once we install the Perl imports package, then we can just pass dump Perl exports a module name, in this case, cPanel JSON XS. It tells us that it is an exporter and that it has 4 default exported symbols and 4 symbols after that that you can import on demand. And that's all good. I mean, this is sort of an interesting module because it has the object-oriented interface, but then also the functional interface. So we can't, we couldn't look at this and say, well, it's got a new method. It's just object-oriented. That's not really the case with this one. Say if we try it with try tiny, it again will tell us that it's got 3 symbols that it can export, catch, finally, and try. HTTP request common that we looked at earlier. That one we can see that by default it will export 6 symbols, but on demand you can import 8. So what happened here is we've got this dynamic file upload, which is actually like a settable variable, and we've also got delete, which was added later on, and the design decision there was not to just export it with everything else, but make it something that somebody would have to explicitly import. So the implementation of Perl imports is basically, we want to parse a Perl document. We'll use PPI for that. We want to find all the use and require statements that are inside the document. Then we're going to try and find out what each module can actually export. We're going to analyze the code to find the symbols that match the possible exports, and then maybe we'll rewrite those statements. So caveat here is we're going to skip pragmas because we're generally not telling them explicitly what we want to import. So we're just going to leave those out for the time being. And then basically what we want to do is say, inside this module, we're using 10 modules. Each of those 10 modules can possibly export these things. And then we're going to match that up with the code base and say, these are things that we think are being used. What are the complements of the list? And then we'll rewrite the use statements appropriately. Okay, now let's try a demo of this. And what I've done here is I'm just going to use it in a Vim integration, and just because I think it makes it easier to see actually what's going on. It's a command line utility, so it's a bit like Perl tidy, where you can just run it on a file, and then it'll either rewrite your file in place, or you can get it dumped to standard out. But in this case, what we're doing is just we're gonna visually select snippets of the code and then tell Perl imports to try to do the right thing. Okay, so in this case, this was the first case that we looked at. So I'm just going to select that and see what happens. Okay, so Perl imports has decided that indeed the get that was available below belongs to HTTP request common. And it's also decided that LWP user agent is not exporting anything. And so it's just going to use the empty parens here. So the interesting thing with LWP user agent, and I've kind of argued this one with people back and forth. Some people might say, well, the brackets there are wrong because there actually is nothing to import. So you don't need to be explicit about that. But those parens act as a form of documentation. And basically they're saying this, if you're looking for imports, don't look here. There's nothing to find. If you're already, familiar with the module, that may seem superfluous to you. But if you're not, that's very helpful. And now in trying to scale this across hundreds of thousands of lines and hundreds of different modules, if you're trying to track something down and in all of your use statements, there's only a couple things that aren't using any kind of arguments or parens, then you can focus in on those. And for example, so if we're looking for some other symbol, we don't know where it came from. We know we don't have to look at LWP user agent here. That's already been taken care of. Okay, so let's try another one here. Okay, so this one, what Perl imports will try to do is give you a consistent style with your imports. So So before we do this, actually, the first import here, you can see there aren't any arguments at all. The next one here, we're really getting a whole bunch of things. And it's a very long line. On the next one, we're importing two things specifically. Here with LWP user agent, we're using curly brackets. With try tiny, we're using slashes, and our spacings, let's call it arbitrary. And then on the last one with mechanize, we're using angle brackets. So let's see what happens. Okay, so what it's done here is with the cPanel JSON access, it's realized we're not importing anything, so we'll just use the empty parens. With list all utils, that was fine. With LWP user agent and mechanize, we now have consistent parentheses. And with try tiny, we've gotten rid of the extra spacing that was in the imports. So if we go back, that was what we had. And this is what we have now. And so you'll notice we actually have less use statements than we started with. And that's because we realized we're actually not using any of these types from database migrator types. So we're just going to get rid of them. Yeah, okay. And then, so that's one of the features that Perl imports comes within, and it's saying, like, if you find something that you're not using, you don't think you're using anymore, just you can just remove it. Okay. So let's look at number 3. So this one's interesting. This is not a .pm file, but we can still use Moose in this way if we want to. That's fine. We're using Moose. We're not using any parens with Moose because that's kind of just the way that people expect to use Moose. We know that Moose exports a small number of things, and so that's not a big surprise to us. And so that as a convenience, we don't need to be specific about our imports. But we do want to confess at line 9. So we're going to use carps confess, and we do want to check if something is blessed. So we're going to use scalar utils blessed. So let's see what happens when we run Perl imports here. Okay, so that's weird. What happened here is it removed the carp confess entirely, and then for scalar util, it removed blessed as well. And the reason it does this is because Moose actually is exporting those things already for you. And actually, we just realized this the other day after having used Moose for a lot of years, because I was running Perl imports on our code base at work, and all these blests were just the scalar util blessed imports were just disappearing, and I couldn't figure out why. But if we use dump Perl exports, and we look at what Moose is doing. So we can see that it does export bless, and it is the bless from scalar util, and it also exports confess. And if you look at the docs, it does that for historical reasons. So I don't know why that is, but those things are already available. So there's actually no reason to import those things again. So one of the interesting things about Perl is that you don't actually get a warning for importing a thing that something else earlier already imported for you. But this now hopefully makes it a little more obvious if you realize what's going on with Moose there. Okay, so that was 3. Okay, so here we have a case where we're using a module 4 different times. Let's see if we can do the right thing here. Okay, so that's now been combined into one use statement using only the 2 functions that we were using. Here we've got a test, and tests are interesting in that when we're using these test modules, we are really, for the most part, expecting them to just import that we'll be able to import a bunch of things into our namespace from the test without explicitly having to name them, because it's kind of a drag. When you're automating it, it's not as much of a drag. You probably don't want to do this, but you can. I find it helpful for the test differences at the very least. For test more, not so much. I've sort of done this as part of the implementation. It was kind of a proof of concept. This gets annoying really quickly with the test more, because you might later on just add a like somewhere, and now your test file won't compile because you haven't explicitly imported like in line 5. You can just go back and add it there later. But that is one way that you can manage it. It's I think helpful when you have a lot of different test modules and you're trying to figure out, oh, where did this one thing actually come from? Especially if you're using something like test most that's bringing like a lot of different things. Sometimes those things can be harder to track down. So this is, anyway, it's something you can do. And I think this is the last one. So here we have an import tag. Now I realized, hopefully this works here. Yep. So it has now converted the import tag to the functions that we're actually importing. The version on CPAN as of this morning has a bug that it doesn't do this, but I will fix that shortly. Okay. That's it for the live demo. And then as far as the Vim integration goes, this is in the docs. But essentially you can sort of set it up so that, yeah, with the visual selection, in this case, I've chosen IAM as the key press. It will just read from standard in. It will check these libraries, these directories, to see if your module exists in there. So that's helpful if you're developing something locally that's not installed. You can set the log level. For Vim, you probably want it to be error or even something that's never going to happen, because that can be a bit annoying. And what I've said in this case is no preserved duplicates, and that means if a module is used twice, just use it once or multiple times. Get rid of all the multiples and just use it in one case. And then also with no preserved unused, I'm asking specifically to delete modules which I don't think are being used. If you're doing this kind of stuff, then definitely you want to make sure that your code's under version control before you do. But I find those to be, for me, helpful defaults. Now, if you want to just ignore a statement, you may just have your reasons that Perl import's just doing the wrong thing, or you really know that something is there for a good reason. And in that case, you can just add like a no Perl imports annotations. It's basically the same kind of idea as Perl critic, but it's not nearly as sophisticated as the way Perl critic does it. Here you have the option of ignoring one line or ignoring a block of lines where you say no imports and then use, so no Perl imports and then use Perl imports after that, so that you can switch it back on. If you're using the command line interface, you can give it a list of modules that you want to ignore, either as comma separated or just in a path with the module name on each line. And that's kind of helpful too when you're running it, because it probably will run into some cases where it's doing the wrong thing. And if you want to just get like 90% of it taken care of, you just ignore those to start with, and you can deal with them later. And also, if you want to say every time this module comes up, I just want the empty parens so that we can document this module doesn't do anything. You can give an explicit list of those so that it can always do the right thing. It can enforce padding for you. So for example, if you tell it, the default will be for it to add some padding at the beginning, like of one space at the beginning and the end of the parentheses. But you can turn that off and you can just have no padding across the board. The nice thing is that when it does rewrite all of your imports, that you'll now have a consistent look and feel. When it analyzes your imports, it will make sure that they're alpha sorted as well. So this DACB then becomes ABCD. And that's just, for me, that's something that I like. I kind of puts things in a predictable order for me. I also like seeing all my use statements in the alphabetical order as well. Traditionally, because that has made it easier to identify when you have multiples. I don't need that as much when I'm using Perl imports, but it's quite helpful. Long lines are broken up too. So if you've got, this line is so long it won't even show up on the slide. But if it's going to be longer than 78 characters, then it's just going to move your imports one to a line, and then it'll alpha sort them as well. So, this does make it easier to see actually what you're getting. And it's, again, one of those things that if you're automating this, it makes it a lot easier to do that than just to be like, looking at this list and then trying to sort it by hand or writing some like macro in Vim to do it for you or whatever. This I find is much easier. It's also moose type aware. So just let's have a look here. So if we're calling dump Perl exports on a moose type library, what it's doing here is it's on the one side, it's telling you the thing that on the left is the thing that's explicitly getting imported into your package, and on the right is the name that you would call it by. So if you want to use any, you would call it any, or you would import bool. But Moose has coercions and type checking as well. And so this recognizes that, if somewhere in your module you're using an isInt, but you're not actually using the int, it will still know to include the int in your import statement, so that you don't get sort of bad information in your imports and things start to break. If you want to enforce these policies or similar ones via Perl Critic, there's a prohibit unused import module, and that will try and say, oh yeah, you've imported bool from this Moose type library, but you're not actually using it, and that'll raise a red flag. Unused include is basically saying you're using this module, but we don't actually see you making use of that module in your code. And then I've got one that I've just worked on recently here, and this is prohibit implicit import. And this, I haven't really road tested it yet, but once I get my entire work code base cleaned up with Perl imports, then I want to implement this policy to stop my friends and colleagues from importing anything implicitly. And you can also look at, there's a prohibit unused constant, and test vars is actually quite helpful as well for picking up variables that you haven't used. So if you're interested in this kind of code cleanup, those are some things that are available to you. So now that we've discussed all this, some best practices around imports: avoid using export tags. HTTP status : is, what does that import? I don't know. And I actually don't really care to find out, because I wish it would just tell me. And there's a way to just tell me. So I would appreciate, like when I'm looking at code, just to have it spelled out. I would say don't be clever. And with exporter, you can do crazy stuff, like you can pass regexes and you can say, give me everything, but not this other thing. And it's why, so if I'm looking at these now, I have to actually know what's going on. So I have to know what they explicitly export. I have to know they use exporter. Now I'm going to look up exporters documentation to figure out what this stuff means. So I would say, please don't do that. If you do insist on doing it, you can set this exporter verbose variable, and then you can run your script and it will dump out a whole bunch of information, but it's probably easier if you don't have to do that. We talked about earlier using empty parens as documentation, because it just makes it explicit that there's no funny business going on here. Use implicit imports prudently. So for Moose, we don't need to be explicit about imports. For data printer as well, that's usually something that we want to use quickly. And there's also some initialization that happens in the import. We need that to run, so we can't just put empty parens at the end of data printer and expect it to perform like it normally would. We talked about sorting your use statements. If you don't do this, and you say you're not using something like Perl imports, when people are sorting out merge conflicts, inevitably you're going to start using modules twice, and then somebody else has to untangle that later, and that's no fun. I would stick with one style of parentheses. You can, when I look at CPAN modules, I'll see like all sorts of ways of bracketing or quoting, and it's not always clear to me what the accepted style is. So, I mean, you can do this definitely, but maybe don't do it. And yeah, as far as bonus slides go, don't require at the top level unless you really need to. So, because when I see something like this here, I ask myself, why is that? Why is this being required and not used? And now I've got to go around and ask questions. And also the require happens at runtime and not at compile time. So there's sort of some subtle differences here. If this module name is not spelled correctly, I won't actually catch that in a compilation test. So those are kind of annoying, but do require when you need to. So it is in this case with exporter, that if I know you've been disciplined, or we've been disciplined about when we do or don't use require, I know that this will have a special meaning. So you can actually use the exporter API without using require, but that actually is an option that's available to you. So only import modules that you need, and only import symbols which you need. Avoid implicit imports at all costs. So those are just all kind of basic things to talk about in keeping your code tidy. And I believe I have hit the 50-minute mark for my talk. So I'm gonna wrap this portion of it up here. Did anybody have any questions? Clap, clap. Thank you.
I would suggest if people have questions, just unmute and ask. Don't raise your hand. Olaf might not be able to see that.
Yeah, I can see like 5 people.
Yep.
I will enjoy reading the scroll back. Yes, thank you.
I have one question.
Sure.
It's always been in my head that when you use something in one place, you're not going to, and you use it again, you don't reload the module. But if use is really a requirement import, and your 2 different uses import different sets of different sets of symbols, that'll still work, right?
Yep.
Okay.
Yeah, which I find confusing, but definitely.
Well, no, it actually makes more sense now after you explained it.
Okay. Yeah, I appreciate that. A lot of this stuff, I was just like, yeah, I kind of tried to dig around and figure out why things.
I want to use these 2 functions here and those 2 functions there. Why wouldn't I do that? Well, you can. It's just a require part. You don't got to reload it. Okay. Thank you.
And if I'm happy to accept pull requests for a lot of this stuff. It's all on GitHub and it's on CPAN if anybody wants to play around with it. It's maybe not as fast as it could be right now. I've got some like primitive caching that I've been trying out for getting around. Like say sometimes you got a module that takes like 2 seconds to load because it's got all this other stuff that is pulling in. So trying to avoid the like compile time hits and things like that. But still, like say at work, if I'm running it on like 120,000 lines of code, it takes me about 40 minutes to run through it. So it's definitely has some room for some speed ups.